Hello, you're looking at the last question on Pure Mathematics 3, so Cambridge Paper 3 from October-November 2023, and we have a fraction, and we have to express this f of x in partial fractions. So let's split it up. There's different cases of this. You'll have a plus b plus c. We here have a outside quadratic, so it's a plus b plus c form. So let's put our first term from the denominator there, and now for b we'll just put 2 plus x, and for the last one, c, we're going to put the second one in its entirety, so 2 plus x in brackets squared. This needs to be treated a little bit differently to the way linear factors are done. So in this part here, like a times what? Well, a times 2 plus x squared, because it hasn't got anything of what is under b and c. B has one of the 2 plus x's, and then also needs the 1 minus 2x that's under the a, and c doesn't require any of 2 plus x. So we've split up 2 plus x, because if you did a square, it would just be two of the same linear factors. It wouldn't make any sense. It wouldn't work. So from there, we substitute in, we've 1 minus 2x, which is x is equal to 1/2, and we've 2 plus x, or x plus 2, which is x is equal to minus 2. So substitute that into the left and right hand side, equate them, find out what the c value is. So we've c is equal to minus 7. Keep going. So x is equal to 1/2. Plug it in. So you get 25 is equal to 25 over 4. A plus 0 plus 0. A is equal to 4. Now at this point, with this particular case of question, we can start equating coefficients, or you can make it x equals 0. So one thing with making it x equals 0, if you were ever trying to find the c part, that's the way this works. It gets rid of all the variables. All the x's disappear, you'd say. But otherwise, you can use it just for putting in the values we have already and figuring it out in that way. A little bit of guesswork sometimes, but after doing these questions a little bit more, you figure it out. So this part here, 13 is equal to 4a plus 2b plus c. We already have a and c. So it's just a nice way of comparing the coefficients, or doing it this way, where we made x equal to 0. So b is equal to 2. And always rewrite the full f of x. So 4 over 1 minus 2x plus 2 over 2 plus x, and then negative minus 7 over that last part. That's your final value for that. Part A. Part B, obtain from the expansion in ascending powers up to x squared, including x squared. Okay, we're just going to treat these separately. So our first term, we've rearranged it so that it's no longer a fraction. And from there, we can, when we've rearranged them all, we can use the binomial expansion. So we'll do them one by one. Okay, so our first, in blue, you see the first one there, we have 1 minus 2x in brackets, so we don't have to rearrange anything there, thank God. So we're going to just have our 4 out front, which is a, as you can see on the right hand side, I've highlighted there, we just have like that in the front. But the other two questions, we have a 2 in both of them inside the brackets. We're going to have to change them a little bit. And you use your binomial expansion, the formula. Again, this is revision, review if you want. It's the last question on the paper. I'm not expecting someone who's never done this before to just be able to take a look at it. Always remember to multiply everything out then at the end. So expanding your brackets. It takes a couple of steps. It takes 3 or 4 steps usually. So take your time and do it right. The next one now, let's have a look. We have 2 times 2. I need to rearrange this to get 1. So 1 plus x. So you're going to multiply your constant out the front, we'll say, so 2. So 2 times 2 to the power of minus 1, which is a half. So 2 times a half is 1. And then you can do it as normal, but fix the x, the variable as well. So 1 plus x over whatever a was. So you'll have 1 plus x over 2 to the minus 1. And you see that in the first line. I've highlighted just the very front there as well. You're given the formula, of course, in your exam. I've done a derivation of this formula. You can see a number of examples as well of binomial expansion for grade 11 and grade 12. And always do them on your calculator, of course, as well. Often the first term, which is just 1, nice, and the second term is often just quite simple, But the third, fourth, be careful and check the signs first as well. Minus times a minus is a plus, so you'll know that it's all positive, and obviously squares are always positive too. The last one here is the most difficult one. So minus 7 times 2 to the power of minus 2. So that's minus 7 times 1/4, which is minus 7 over 4. And from there again, replace with the x, so x becomes x over 2. And again, once you've rearranged that, it's just plugging in for your formula, which you should be used to after doing it a few times, and that should be it. So that's our first 3 terms, all we need. So minus 7 over 4 is our first term, plus 7 over 4, x, and then 3 times 21, so 21 over 16. So just multiplying across with these things as well. Just keep it simple. We're dealing with fractions. And we don't need any more than x squared. That's what the question stated. So from there, you can start putting these together. So just take them one by one. 4 plus 1 plus minus 7 over 4. Put them together. Write it all out. I circle the first one. I might underline the second one. You might highlight the third one, just to make them as easy as possible for you to do. So you'll end up with constants like 13 over 4, which is what I just mentioned. It's 8x minus x over 2 plus 7 over 4x is 37 over 4x. And lastly, 16x squared plus x squared over 4, which is 1/4 x squared. And then minus 21 over 16x squared. Get your calculator out for this. Use your calculator. This is plus 239 over 16x squared. And lastly, just to do some validity, because you often get asked this anyway, a set of values of x for which the expansion of part B is valid. So we have 2x minus 1. So minus 2x is less than 1, always less than 1. And so x is less than a half, 1/2. And then x over 2, again, modulus here, so positive value is less than 1, of course. And so mod of x is less than 2. Just multiply across there. And of course, the answer is mod x less than 1/2. It's the only one that you can draw a line graph here as well if you want. You can't use DESMOS, but of course you can put this through and check all of these details on your graphical calculator as well when you're practicing. And remember, this is the last question on the paper. It's probably not actually the hardest question on this specific paper, but it's long, it's tough in that way. There's a lot of details, and it's very good for your practice for this particular topic, which is further algebra, pure 3,